Let's study parallelogram law of vector addition. This is another law after triangle law of vector addition. This is parallelogram law. It says that if two vectors are acting on a particle at the same time, if two vectors are given, okay, and they are represented in magnitude and direction by the two adjacent sides of a parallelogram, okay. Two adjacent sides of a parallelogram means what? If this is a parallelogram, these two sides will be adjacent sides, okay. If two vectors are represented by the adjacent sides of a parallelogram drawn from the point, then their resultant will be diagonal from the same point. This is the point and this diagonal is the resultant, okay. Suppose it is vector A and this is vector B, the diagonal, this one will be the resultant vector, okay. If two vectors are given, suppose this is one vector, this is another vector, okay. This is vector A, this is vector B. These two vectors are given, okay. Then what we need to complete this as a parallelogram. To complete it as a parallelogram, we will draw a line parallel to this one, this two parallel and this parallel. Here it is. It will be a parallelogram and simply join the diagonal, okay. And this is also one diagonal. This is also one diagonal of this parallelogram, but this diagonal will not be taken. This point is important. Drawn from the same point. Which point? At which this adjacent sides meet, okay. So this point will be taken as important point. Suppose it is O, suppose it is A, you can take, suppose it is B, you can take, suppose it is C, you can take, okay. So the resultant OB will be equal to what? OC vector plus OA vector, okay. That is R equals to vector A plus vector B, okay. This is no new concept. This is no new concept. This is very similar to triangle law of vector addition. How it is? Let's see. That is, you can give it a topic like similarity with triangle law. Let's see. What is its similarity with triangle law? What was triangle law? The two vectors were in this is same manner, okay, and the third side of the triangle in opposite manner was the resultant, okay. This was the resultant. This was vector A and this was vector B. In the previous video we had seen this, and now in this parallelogram, what is this? This is two sides of a parallelogram. These are the two sides. We simply take the diagonal as the resultant here. We simply complete this parallelogram and we take the diagonal. This one is the resultant. This is vector B and this is vector A. Take it like in this. Now let's see what is the similarity. In triangle law, this vector can be put here also, just parallel, no change in angle, no change in magnitude, so vector can be put here. This vector is put here, okay. This is vector B, okay. Only the position is changed and nothing else, neither magnitude nor direction, okay. This position is changed here, then join it. What will happen? What happened here? Here it happened that it made the parallelogram with adjacent sides A and vector B, and the diagonal is the resultant. So triangle law can be converted into parallelogram law. This is nothing new. This is parallelogram law of vector addition is nothing new. This is an extended version of triangle law, you can say, okay, and it's nothing. You can solve problems and numericals by doing by using any of the laws. If you don't know even what is parallelogram law, you can use triangle law. If you don't know triangle law, you can use parallelogram law. That is the same thing, okay. Simply replace the factor, simply position your factors according to your convenience and use any of the law, okay, for addition of two vectors, okay. So there is no difference, no much difference between parallelogram law and triangle law. Both seem to be the same, okay. Thank you.